All right. In today's lesson, we have a couple review slides on proportions before we actually get into the lesson on section 11.1. So we start out here with the simple definition of what a proportion is. A proportion is a statement of equality between two ratios. Of course, a ratio is a fraction. So a proportion is two fractions set equal to one another. So here we have a quick example. It says in a photograph, Dan is 2.5 inches tall, and his sister Emma is 1.5 inches tall. Dan's actual height is 70 inches. What is Emma's actual height? So we're going to set up a proportion. It says the ratio of Dan's height to Emma's height is the same in real life as it is in the photo. Let X represent Emma's height. Set up a proportion. So here's what we see. We have a proportion here, right? Two fractions set equal to one another. On the left side of the proportion, we have the fraction that is made up of Dan's height in the photograph over his sister's Emma's height in the photograph. On the right-hand side of the proportion, we have the fraction or the ratio made up of Dan's actual height over X, the variable that will represent Emma's actual height. Now, there are many ways to set up a correct proportion, right? For example, if you look at the top number in each ratio, Dan's height in the photograph and Dan's actual height, those numbers correspond to one another. If you look at the bottom numbers, Emma's height in the photograph and Emma's actual height. When you set up a proportion, in order for it to be correct, you have to have corresponding pieces in the same fraction and also on top of the fractions or on bottom of the fractions. Okay? Like this proportion, we could have set up as Dan's height in the photograph over Dan's actual height equals Emma's height in the photograph over Emma's actual height. Right? We're still keeping corresponding things relating to one another. We've just sort of rearranged the way that they're positioned. All right. So we have our proportion. Now you should remember how we solve a proportion. Cross multiplication, right? So if we want to solve for Emma's actual height here, we're going to cross multiply. 2.5 times x is 2.5x, and 1.5 times 70 is 105. Now we can solve for Emma's actual height by dividing both sides by 2.5. Emma's actual height is 42 inches tall. All right, one more example before we get into the lesson. So this is a proportion. Looks a little more complicated than the one on the previous slide, right? Because we have some algebraic expressions involved. 3x minus 13 over x plus 40 equals 23 over 10. Solve this proportion. Okay? So we cross multiply, and we get 10 times the quantity 3x minus 13, and that's going to equal 23 times the quantity x plus 40. So we distribute and get 30x minus 130 equals 23x plus 920. So we're going to add 130 to both sides. That'll leave us with 30x equals 23x 1015. 50. Okay, 1050. Okay, subtract 23x from both sides and get 7x equals 1050. Divide both sides by 7, x equals 150. And as we know, with all algebra, when you solve an equation, you can take the answer, plug it back in to make sure it gives you a true statement, right? All right, we are now ready to start the lesson. So section 11.1 is on similar polygons. Two polygons are similar if and only if the corresponding angles are congruent and the corresponding sides are proportional. All right, the statement CORN is similar to PEAS. So this statement right here is what we call a similarity statement. It's telling us the two quadrilaterals are similar to one another. Just as in statements of congruence, the order of the letters tells you which segments and which angles in the two polygons correspond. So just by looking at the statement, I'll show you the actual quadrilaterals here in a second, but we know, for example, that side CO would correspond to side PE, and side OR would correspond to side EA, and so on, right? We talked a lot about this with congruency also. So now when we actually look at our quadrilaterals, we can see that this actually is true. So let's start with the angles, because the first part of the definition says that corresponding angles must be congruent. Well, we start out in the diagrams, they show us that angle R is congruent to angle A. They correspond to one another, and they are congruent. They also tell us in these other statements, angle C is congruent to angle P, angle O congruent to angle E, angle N congruent to angle S. So we've taken care of that first part of the definition of similar polygons. Then we would have to check that corresponding segments or sides are proportional. So side CO corresponds to side PE, right? They're writing that right there as a ratio or as a fraction. Now, whatever that fraction is, it has to equal what side OR over side EA equals, because those are now corresponding sides. And same with RN over AS, and finally NC over SP. You have to have corresponding angles congruent and corresponding sides proportional in order for them to be similar polygons. So in this first example, it says in the figures below, corresponding angles of square SQUE and rectangle RCTL are congruent, but their corresponding sides are not proportional. So obviously, these two quadrilaterals would not be similar, right? We only have one of the two characteristics of the definition of similar polygons. In the second example here, in the figures below, corresponding sides of square SQUE and rhombus RHOM are proportional, but their corresponding angles are not congruent. So again, not similar polygons, right? In both of these cases, you're getting one of the two characteristics, but not both, and so not similar polygons. All right. So in this example, we are being told in the similarity statement right here that quadrilateral SMAL is similar to quadrilateral BIGE. Small is similar to big. We have to find X and Y. You can see that X is the measure of side EG in the quadrilateral on the right, and Y is the measure of angle I. All right, let's start with the easy one, the angle. What's the measure of angle Y going to be? 83 degrees, right? Because we know corresponding angles have to be congruent. We can clearly see that angle M is corresponding to angle I, and so Y has to be 83 degrees. All right, now we have to find X, the measure of side EG. There are many proportions that we could set up here and be correct. 24 over 18 equals X over 21. So we have side EB, which corresponds to side LS, and then we have side EG over side AL, right, that correspond. All right, so we like that. So another proportion could be 18 over 24 equals 21 over X. Very similar to our first proportion, right? Matching up the corresponding sides in each ratio. But here, in our second proportion, we've taken the left quadrilateral and put it on top, as opposed to on the bottom. And we've taken the right quadrilateral and put it on the bottom instead of on the top. So a third possible proportion would be 18 over 21 equals 24 over X. So let's talk about how this is similar and different to the others. So in the first two proportions, we took the left quadrilateral, and in the first one we put it, let's see, on the bottom. On the second one we put it on the top, and in the third one we put it in the left ratio. Right? But they're still corresponding to one another. It's still fine. And we took the right quadrilateral, and in the first one it was on top, and the second one it was on the bottom, but in the third one it's in the right ratio. Right? As long as you match up the corresponding pieces correctly, your proportion will work. And here's why. When we cross multiply, 24 times 21, 24 times 21, 24 times 21. Right? 18 times X, 18 times X, 18 times X. That's why all three of these work. Now, there are proportions that would not work. So a proportion that might not work is 18 over X equals 21 over 24. So let's examine this. So 18 comes from the left quadrilateral and X comes from the right quadrilateral, but those sides do not correspond to one another, right? And then the same thing, 21 comes from the left, 24 comes from the right, but they don't correspond. So yeah, that would be an example of a proportion that does not work. Okay, so let's solve for X. 18x equals 504. Divide by 18, x equals 28 feet. All right, next definition is dilations. If one polygon is a dilated image of another polygon, then the polygons are similar. Similar figures are dilations of each other. And we know from previous study that a dilation is when you increase the size but do not change the shape. And actually, a dilation can increase or decrease the size but does not change the shape.